Hello, welcome to the course of Git. We are going to start with the history of version control system. Before the version control system came, there was no version control system available. Then the history can be divided into three generations. The first one, file lock, second one, centralized version control system, and third one, distributed version control system. So when there was no version control system available, there were so many issues. For example, developers has to take backup regularly. If they want to do a collaboration in a team, it was really headache. It was not possible at all. So we can say there was a need of version control system. So first generation version control system came into market around 70s and 80s. That was file lock. Means if one developer is working on a file and other one wants to work on the same file, that is the shared file, then the first developer, while making the change, will lock the file until and unless he has done his work. The other developer can't do the work on the same file. Once the first developer has done his work, he releases the lock, then only the second developer can do the work on the same shared file. But at least they can work on the shared file. That is the advantage. But drawback was also there. The developers has to wait till the other developers are releasing the lock. The second generation centralized version control system, once again two developers can work on the shared file. Now there is one scenario, that is merge before commit. The examples are there on the late 1990. Now let us talk about the scenario of merge before commit. Now let's say there are developer 1 and developer 2. They both are working on a shared file. So developer 1 has done his changes and he has put his changes on the shared file. Now developer B wants to put his changes on the shared file. So at that time he is blocked. He cannot directly put the changes on the shared file because the shared file is changed now. Developer 1's changes are there. So he cannot directly put the changes over there. So what is the solution? He has to take the changes from the shared file to his local system. He has to do a merge. So developer 1's changes and developer 2's changes are merged into developer 2's system. And then after that he is going to put back the changes to the shared file. So now the shared file is going to have changes of both the developers. So it was merged before commit scenario. The third generation, that is distributed version control system, it was the one big innovation, and the innovation is that commit before you merge. So let us have the scenario of commit before you merge. Examples are there, that is going around 90. Distributed version control system, we can say that is a big innovation. You can have a latest copy of your source code. Apart from that, you can have a whole history of changes with time and the developers as well. To understand the distributed version control system, first you should understand the directed acyclic graph. In the graph, you can grow from one direction to another direction, means from 3 to 2, 2 to 1, that is allowed. But if you want to go back from 1 to 3, that is not allowed. So that is directed acyclic graph. You have nodes, you have edges. Edges are going from one direction to another direction. Now, in related to distributed version control system, there are node. Whenever you do a commit, it will create a node, and each node contains information about which files and what text were changed. The node will have all the details about changes. Each node contains information about the parent node. Each node is uniquely identified by a hash code. Hash codes are calculated using the changes in the code and the parent node. Hash codes are quite large enough numbers. We can significantly use 6 to 7 digits that will identify the each node. Now let us discuss the workflow of distributed version control system. Let's say on server there are 3 commits, that is 1, 2 and 3. There are 3 total commits on the server, and developer A is taking all the commits from server to his local system, that is clone. So now developer A is having node 1, node 2 and node 3. So developer A is doing some changes and he is doing a commit. So that will create a new node, that is, let's say node 4. On server there are still 3 nodes. On developer A there are 4 nodes. So developer A is going to do a push and he is going to push the changes on the server. So server had only 3 nodes. So using the has code, server checks which node it does not have, that is node 4. So that node 4 is pushed to the server. So after the push, server again have 4 nodes, that is same as of developer A. But what if someone has already posted some changes on the server? Meanwhile, the developer A is doing his work. So on server, let's say there are 5 nodes. Now developer A is trying to do a push, that is node 4, and it cannot be added after node 11. Why? Because node 4's parent node is node 3. If you add the node 4 after node 11, that is different hash code. So developer A needs to pull his changes from the server that will be merged into his local system. So developer A will be making pull node 10 and 11 are pulled from server to his local system. They will be pulled as a child of node 3. Now developer A's local machine has two AND nodes, that is node 4 and node 11. They both are AND node. So it will be confusing for the server which node to make a build. It should make a build on the version 4 or it should make a build on the version 11. So we need a merge over here. So a new node is added in developer A's local PC, that is node 5, that will be having a parent node as node 4 and 11, that is a merge node. So after the merge, changes will be pushed to the server. So it was introduction to distributed version control system. Now let's have introduction to Git. Git is a version control system, that is distributed version control system. It keeps track of the changes done in the code of software. To work with a team, it allows you to collaborate in a team. It will not mess up your code. It's open source tool. Now Git is not going to store all of your source code. It is just going to store the changes that you have done. So memory wise, you can say it is not that much problematic because it will just have track of the changes that you have done or all other developers have done. There is one more word related to Git, that is repository. It is the place where you are going to store your code. Git is local software you can install on your computer. Now let's have introduction to the workflow of making a commit. So from working directory, first it will be moved to staging area, and from staging area it will be moved to repository. So basically you have to do two things. First is git add and second is git commit. We are going to see all the commands, but it is just introduction to staging area. So let's say you are making changes in your file. So either it can be modified, it can be not modified, it can be tracked or it can be untracked. Whenever you add the files, that will be only the tracked and modified files will be added to the staging area. From the staging area, whenever you do a commit, it will be taking the files that are into the staging area. All other files, let's say untracked files or tracked and unmodified files, they will not be added to that particular commit. So let us start practicals of Git.